Hey guys, in this episode, Randall Carlson responds to your comments from our last episode. We start a brand new series today regarding sacred geometry, which will continue moving forward. And Randall also talked about the status quo science that stands in the way of new discoveries. Now, if you guys want to understand the science of why scientists get caught in their dogmatic attachments to their position, regardless of the new evidence that's coming forward, pick up this book, Mind Hacking Happiness. This title does not represent all the coolness that's in this book. It explains how the human mind works. The SEALs on this show called this book one of the best mind training manuals on the planet. So if you read it, you'll be able to take control of your mind for the first time in your life, which is amazing because you can basically turn off all your negative shit and turn up all your happy stuff. But it also explains the science of why scientists get so attached to their dogmatic positions and then start to ignore future evidence that comes in. So pick it up. You can get it at Audible or Amazon, Mind Hacking Happiness. You can get it free if you don't already have an Audible account just by signing up for the free trial at the link below. Money from the sale of this book helps support this show. Here's Randall Carlson. Hey guys, welcome to Two SEALs and a Walrus, the only show on the internet that has two United States Navy SEALs as co-hosts. I am your co-host, Sean Webb. To my right, as always, we have United States Navy SEAL Sniper Medic Ben Johnson. And to his right, we have United States Navy SEAL Doug Moulton. And on the show today, we have Randall Carlson from Atlanta, Georgia. How are you today, sir?
I'm doing well.
Awesome. You know, it's been a few weeks since we had you on last time, and we had a ton of views on the first video and a ton of comments, and I wanted to address some of those comments so that we can have kind of an interactive dialogue with some of the viewers that we have and let them know that, hey, this isn't just a one-way communication. You guys can actually say stuff, and we'll listen to you, and we'll ask our special guests when they come on about the questions that you pose. And so if you're up for it, I'd love to go through some of these comments and just have you quickly respond to them if you got something to say. Or
Sure.
And just to bring our listeners up to speed, these are comments from our last conversation, which if you have not heard it, you can link to here, which was basically Randall talking about some Drumlin evidence that yet again supports the hypothesis that multiple comets might have ended the Younger Dryas. And with our first comment, there was a guy who'd mentioned in northeast Iowa that they have over 600 feet of dirt and materials on top of their bedrock, and it's mainly flatland. That goes to show how ground up to dust everything became in the wake of the massive mega flooding. Have you done a lot of research into the flatlands of Iowa and some of the middle states in the United States?
The flatlands of Iowa, the term for that is a glacial outwash plain.
Okay.
So the flatlands are essentially just beyond the margin of the great ice sheets. And as they melt, they carry enormous amounts of sediment, and that sediment gets spread out across, literally thousands of square miles of the Earth's surface. So yeah, you'll see that glacial outwash plain in Iowa. You'll see it in South Dakota. You'll see it in Wisconsin and Illinois. Yeah, so that's part of the whole sequence of the glacial meltdown.
Okay. Now we got another question from about the Niagara Escarpment. Hi guys, this idea of mine, this is from Robert Kosher, by the way. This idea of mine is out there, but the more I think of it, the better it fits. The Niagara Escarpment is what remains of an impact zone at Saginaw Bay, Michigan. The escarpment seems to be the rim of the crater that eroded away. Search Niagara Escarpment on Wikipedia and look at the map. I live west of Toronto. I know this area of the escarpment very well. I grew up here. Outside of this rim, the escarpment has extensive erosion, but inside the rim, it doesn't. I think the Niagara Escarpment is a smoking gun of evidence that Saginaw Bay impact hypothesis. Mr. Carlson needs to know about this, or do you already?
Well, I'm familiar with the Saginaw Bay.
Okay.
Excuse me. That goes to Tony Zamora's work on his proposition that the Saginaw Bay is an impact site based upon his study of the radial distribution of the bay formations, which are found in Virginia, North and South Carolina, Georgia, and Nebraska, which have a radial pattern which he attributes to what he calls the ice boulder hypothesis, that there was an impact into Saginaw Bay. The debris, which was the form of ice boulders, was thrown up into the sky. It fell back to Earth. That's a very controversial idea. I know some people that think it's pretty plausible and others who don't. So I don't accept it, but I don't reject it either. I'm just waiting to see more definitive evidence. Now, as to Niagara Escarpment, it could be. I mean, it could be that the original fracturing of the bedrock that created the escarpment in the first place could be related ultimately to impact. I don't know. I haven't had a chance. I've seen Robert's comment before. I think Robert's comment came into the podcast that I'm doing on Cosmographia, but
Okay.
I haven't really had a chance to look into the bedrock, so I don't want to sit here and pretend I'm an authority on the formation of the Niagara Escarpment, but it
Sure.
certainly could be. That's what
Okay.
I'm saying. It could be.
All right. Well, we've also got a comment from someone in Ireland. Hi, fascinating stuff. I was born and raised in a drumlin swarm that stretches from the Atlantic coast of Ireland to the Irish Sea, and this is from one Groggy. It lies approximately in the southern portion of Ulster and formed the pre-modern times significant defensible border for the Ulster peoples. Only after traveling in later life did I realize how significant a landform this was, but I've never found a good explanation for it other than it's a type of glacial landform, other than the relatively small glacial centers of Donegal Mountains, Spurgeon Mountains, Lough Neagh, and we don't have large expanses of ice cap bearing on our land to the north, such as your Laurentide ice cap. To our north, in the Atlantic, we have a portion of the continental ice shelf that then drops into Rockall Trough. I suspect this maritime topography would capture catastrophic melt. The pressurized water hypothesis, however, strikes me as the best mechanism I have heard to date. Have you looked into drumlins in Ireland?
To some extent, yeah. I'm aware that they're there. I've certainly read some papers on them that have been published over the years. It's a result of, if you're accepting this hypothesis of, as he referred to it, pressurized subglacial meltwater, that was the Fennoscandian ice sheet that covered the northwestern portion of Europe. So it covered very roughly, the northern half of the British Isles, which of course weren't islands then, because of the fact that the lowered sea level dropped below the depth of the North Sea. And so what were the British Isles were connected to the European mainland. And right there where those Irish drumlin swarms are, that was the southern margin of the Fennoscandian ice sheet, it's called, which reached from there all the way probably as far as the Ural Mountains and covered all of Scandinavia.
Mm-hmm.
So, yeah, and what's interesting about that to me is it suggests that there was a catastrophic melting of that ice sheet as well as the Laurentide ice sheet.
You know, that would certainly make a whole lot of sense.
Yeah. And what that does, though, is it really expands the scope and scale of this melting event, which I'm still struggling with, trying to come up with the most plausible explanation for that. And it seems at this point that there were 3 pulses of melting that ultimately took down the ice sheet beyond its ability to regenerate. And the timing of those seems to be over a 3,000 year period, roughly.
Mm-hmm.
And from 14.6 to about 11.6, that 3,000 year window. I'm not sure of the exact dating of the melting of the Fennoscandian ice sheet because I haven't looked into it to the depth and degree that I have the North American ice sheets. But yeah, that's certainly something that needs to be looked into because we are certainly seeing the effects of a global phenomena.
Right.
That's clear. So yeah, the Irish drumlin swarms is very fascinating. I almost am tempted to pull it up here, but I think that if we were going to be talking about sacred geometry today, but you know, we could tell you what we could do is we could do a future one. Whatever comments that come in, we could actually delve into that in a future podcast to a little greater depth, and I could have some images and yeah, there's a very large drumlin field in Wisconsin.
Right.
Also, and both of them have sort of essentially a radial pattern, which you have to kind of picture a flow of water coming under the ice sheet.
Right.
Probably in a like an inverted tunnel. That water is moving through. It's being fed from some epicenter of melting. That water is being forced through under pressure. And at some point, as it gets to the glacier margin, where typically what you do is you find the drumlins under places where the ice is not quite so thick. And like, for example, the drumlins that you see in western New York near the Finger Lakes, they basically start in form between the southern margin of Lake Ontario and the northern margin of the Finger Lakes, and they're radial. So in other words, it appears that if you follow the axes of these elongated hills, they point to an epicenter, which to me is a very interesting, because that seems to imply that there was some source of energy at that melting center.
Yeah.
Capable of catastrophically melting the ice. Now, was that, but on the other hand, we've got this general overall melting as well, because see, Sean, it's really difficult to try to explain and understand how you get from the climate of the Ice Age into the modern climate in a few thousand years, especially when you think about if you're going to try to duplicate the climate of the Ice Age, right? Going back 15 to 20,000 years ago, say 15 to 25,000 years ago. If you're going to try to duplicate that climate and you turn to modern analogs, modern examples, all you got is the South Pole, Antarctica,
Right.
You got to think that you're going to take this massive polar ice cap that flanks the South Pole of the planet and set that thing on top of North America, so that you're basically buried almost 2/3 of the North American continent under this massive ice sheet that reaches from the Atlantic to the Pacific and from the northern United States up to the Arctic Circle. That's very interesting. How do you get, say, from a climate like we're in now to where half of North America is like the mother, South Pole?
Right.
Nobody really, I've been perusing the literature on this stuff literally for decades, and there's a lot of ideas, and somebody will come up with an idea, somebody else will shoot it down. Somebody else comes with a new idea, somebody else shoots it down. There's no consensus on that at all.
Yeah. I got to tell you, even in the comments that we got, and there were side comments of, have him give up his Masonic secret knowledge, and let's talk about the CO2 fallacy, or that it's only one chemical that we're tagging for this climate change event, stuff like that. But there was one person who was genuinely flabbergasted. He's like, ask Randall to explain. This is from Bitter Root Backroads. He says, ask Randall to explain where enough heat comes from with a comet asteroid impact to melt a mile thick ice sheet covering half of North America, big question mark. The Chelyabinsk meteor largely burned up in the atmosphere and was bright as the sun. The pieces that didn't burn up fell to Earth and were found by looking for the holes that they made in a foot of snow. Nothing melted. A piece of it fell into a lake, punched a hole in the ice, which then froze over again. Comets may be largely made of ice at deep space temperatures. Whatever heat an extraterrestrial object creates due to friction with the atmosphere seems very rapidly dissipated. Now, we know that the physics, with the two guys sitting here on the couch, right, we know that the physics of the speed of an object certainly relates to the energy and the heat energy that can be delivered by that small little piece of lead that you're firing based on your muzzle velocity, right? As you increase muzzle velocity, what happens? You guys both went through sniper school. Give us a little bit of the science.
The 30,000 foot view is this. You're taking something that it has energy. It's moving through space at a certain speed, and the speed is about to be decreased to zero.
Yes.
So that means its kinetic energy has to be transferred to something else.
Right.
So whether it's ice or not, you're moving the energy. The law of conservation is you can either create nor destroy energy. It is just transferred.
Yes.
So you just think of it simply as you're taking something that weighs millions, billions of tons, and you're making it go 0 miles an hour.
Right.
How are you doing that?
Right. And the other side of that answer to this science is, that we talked about last time with Randall, was Shoemaker Levy 9 impacted Jupiter, right? And it was basically a half a mile wide, a little bit bigger than the Apophis asteroid that's kind of circling and threatening, potentially hitting us. Like, they weren't certain a decade ago whether or not it was going to hit us in 2029. You're talking about instant 30,000 degrees Celsius heat, plumes of 3,000 plumes of heat 3,000 kilometers high, a storm on Jupiter that was 3 times the size of the Earth, period. Okay, so one of those things hits Earth, it will create the heat required to melt through an ice cap. I mean,
it doesn't matter if it's ice. I think people might get hung up on that.
Yeah,
I feel like
the
it could be
size and the
tissue
speed,
paper.
right? The size and the speed create the heat energy
Yeah.
that is associated with that. Is that
Yes, and you got to bear in mind that these things, as they approach the Earth, are going to be moving roughly 10 to 20 times the speed of a rifle bullet. If you assume typical rifle, but what 1,200 feet per second, 2,000 feet per second, is that about right?
Yeah, 2,500 ish.
2,500. Okay, for the
Depends on the
high-powered
round,
rifles today. Yeah. Okay, so so you could figure 10 times the speed of a rifle bullet if you're going at 2,500 feet per second is about the atmospheric entry velocity. So at that speed, it takes about a half second for it to traverse the entire depth of the atmosphere, from the 8 miles of the atmosphere from the top basically down to the surface of the Earth. So if it's an airburst, it dumps its energy into the atmosphere. If it's a surface impact, most of that energy is going to get, like you were talking about, Doug, it's going to pretty much be dumped into whatever the target is, what's going to happen. And when you're looking at a major impact, like of a kilometer-sized object, you're looking at, a few million megatons of TNT, million megatons. I mean, so you're looking at an energy range that's going to be equivalent. Even a small impact is going to dump energy equivalent to the entire nuclear arsenal of the planet during the peak of the Cold War, somewhere around 10 to 12,000 megatons of energy, and that's a small impact. And again, because the energy of, like you were saying, it's a function of its velocity. So yeah, there's no problem there. There's no problem with an object, say, 3,000 to 6,000 feet in diameter, dumping a whole lot of energy into the ice sheet. But there's a legitimate question there that he's got, and that is that one impact would cause catastrophic melting over a region. You might look at, say, an area. You can figure that in an impact of an object, you basically look at like crater diameter to object diameter. There's a typical ratio, and the crater diameter will be typically 10 to 20 times the object diameter. So if the object is a mile wide, you're going to look for a crater 10 to 20 miles wide, right? So also the full, probably if you're looking at a mile thick ice sheet to a mile and a half thick ice sheet, an object whose diameter is equivalent to the thickness of the ice sheet is going to be able to penetrate and melt ice from the surface to the ground underneath. But even there, if you're looking at a radius of destruction, let's say of 10 miles in each direction, you're still not looking at enough to melt the whole goddamn ice sheet.
right?
So how do you do that? Well, there are two things that I would look at that I think are and one I think is more likely than the other, and that would be a multiple impact event, which injects enough water vapor into the atmosphere to induce feedback process. You have to somehow get feedback processes in there. If you get a massive rain out, for example, that rain can trigger further melting. The other thing would be a solar component. And I think that's a very plausible explanation, especially when we look at the fact that there might have been 3 episodes of melting. And there are now impact proxies that are quite well established that are associated with the 12,900 year ago Younger Dryas boundary, right? There are no such proxies, to my knowledge, at this point with the 11,600 year ago melting or the 14,600 year ago melting. What caused that? See, I'm not going to sit here and pretend that I have the answers to this. What I am going to say is that it's a hell of a mystery, and nobody's figured it out yet, really, in all its details, and that's why I'm so fascinated by it.
Right.
It's a bona fide mystery, and I think that in order to fully understand, we have to look at all possible explanations. And there's specifically evidence that would suggest impacts of probably cometary debris. That seems to be the most likely candidate. Yet, like the 14,600 melting, what caused that? Could it be the sun? I don't know, but it's, to me, the more I learn about the sun and how dynamic the sun is, the more plausible it becomes to me that the sun may have played a major role. You know, Robert Schoch has been advocating a solar trigger for the catastrophic melting, and I think he's probably at least partially right. He tends to exclude impacts. At least the last time I had any conversation with him or interaction with him, he was excluding the idea of impacts. He may have moderated his perspective on that somewhat since then. But I certainly don't exclude, while I think that the impact hypothesis now is very rigorous and has a lot of evidence to support it, I do not reject the possibility that the sun played a role, especially since I've learned in the last few years about the discovery and the role of sun grazing comets,
Right.
which seem to be related to solar activity. In other words, when the flux of sun grazing comets falling into the solar chromosphere increases, it seems like solar activity increases. There's more solar storms or more coronal mass ejections. If that's the case, there may be a relationship between the influx of material into the solar system, the amount of material swept up or that falls into the sun, and a solar response to that, which to me is an extremely fascinating and fertile area of future inquiry. And I'm really looking forward to, getting more data from the sun and the connection between the infall of sun grazing comets and a solar response. And I wasn't prepared to get into that today, but I've got some very interesting information with slides and everything that we could do another episode, and I could come prepared to talk more about that.
Sold.
Yeah. Done and done.
Well, we've got one other on that tack, one other comment that I wanted to cover before we get into today's topics. It was Joyful Diamonds. It says, "Thank you, gentlemen, for a lovely show. Dear Randall, I have been working on a puzzle here in Snohomish County, Washington State, where the Cordilleran ice sheet was located during the Younger Dryas period. We have a hypothesis that many of the small lakes in this area are impact craters where meteorite material penetrated through the ice sheets into the Earth's surface. Nano diamond specimens are easily found at every lake I have researched so far. My avatar is a picture of an extraterrestrial nano diamond impact diamond that was once graphite in form before it transformed into a nano diamond. Nano diamond is like thousands upon thousands of nano-sized diamonds bonded together in a quasi-crystal structure. Quasi-crystal gemstones occur when unimaginable heat and pressure are present in their formation. What is also extraordinary about them is that some possess the classic wind-manstatin pattern that you can find in iron meteors. Now imagine a wind-manstatin pattern in a nanodiamond. My dear beloveds, I have worked with these precious gemstones for a while now and can attest that whatever made them manifest in their present form was absolutely catastrophic to the entirety of our planet. Much love and light to you all. Thank you for what you do." And that's from Joyful Diamonds. Thank you very much for that comment, Joyful.
Yeah, what a great comment. Now, I have not explored the area of Snohomish County. Let's see, I believe it's just to the east of Puget Sound.
Okay.
In the North Cascades. And that would have been under the ice sheet. Yeah, the ice sheet, if you look at the Puget Sound lowlands just south of there, that was a lobe of the ice sheet that came down there. So I find very interesting. I would like to get you to forward that email to me so I can reread it.
Okay.
And digest it.
Sure.
And do a little map work on those lakes. I'm going to be out there again next summer, so maybe I can segue over to that area and have a look at some of those lakes. But yeah, the fact that this person here is finding nano diamonds and things, this is very interesting. Sounds like somebody who's got some professional background, or certainly done their homework. Knew about impact proxies and some of the amounts of pressure involved in creating those impact proxies. So yeah, I would like to look into that further, because that would be confirmation of the idea right there.
Yeah, I agree. Well, one of the things that I wanted to continue our podcast with today, to switch gears, is to discuss, we've been talking about these impact events and these catastrophic melting events that the Earth seems to be showing us evidence that supports. Half the megafauna on the planet died at that point, and the humans probably had a very tough time as well. And so a lot of what we would call culture or our humanity was removed from the planet as well, most likely, including potentially some folks who had a better understanding of our local solar system than we do. And there's evidence of that in some of the historic discoveries that we've made that are connected with the diameter of the Earth, the diameter of this moon, the diameter of the sun, that are represented in architecture, that are represented in art, that are represented in a number of things that humans did back then, that gives us very definitive evidence that they knew a lot more about the solar system than we did. Up until just recently, we started to laser measure things and figure out what the exact diameters of our celestial bodies were, that type of thing. You've done a lot of research into that. Is that accurate?
That's mostly accurate, Sean.
I love being mostly accurate.
It's the best we can do.
A lot of the evidence that points to that is I would say is post-Ice Age, right?
Okay.
But when we start looking at some of this anomalous evidence and data that would suggest what you've just outlined there, we're pushing it back, and what we see now is that things get older and older, and
right.
There are, clearly there's evidence that somebody was tracking things with a high degree of accuracy, 4 and 5 and 6,000 years ago. We find, architectural examples all over the world that go back now to between 4,000 and 6,000 years ago that seem to suggest a very intense interest in the astronomical domain and a way of perhaps measuring not only the scale and distances, but also some of the temporal frequencies. So when we get back to the Ice Age, of course, the problem is that the changes that engulf the Earth in that transition out of the Ice Age were so sweeping and so drastic that the former world only remains in little scattered bits and pieces. So we're kind of in this situation now where, we find a little piece of something that, here's a landscape that goes back to the late Pleistocene. I'll give you an example. The driftless area of southern Wisconsin, southeastern Wisconsin and northeastern Iowa and southeastern Minnesota. Let me see if I said that right. Southwestern Wisconsin, northeastern Iowa, and southeastern Minnesota. There's a region there called the driftless area. Now, the driftless area, over at least 4 successive glaciations, the glaciers came, parted, and then rejoined south of this particular area. And so where much of the other areas were basically pulverized and bulldozed by the glaciers coming in, this driftless area is very hilly. If you look on digital relief maps, you will see that you've got pretty much flat areas surrounded by this very hilly area. So here's an example of a landscape that has been preserved, right? Now, but then the problem is during the melting, that area got submerged, but it didn't get bulldozed to the same extent. When you look at the pattern of extinctions, what you see is that there are places where life seems to have survived by whatever means, probably just the luck of the draw. And when you have basically a devastated landscape, life reclaims that landscape from these zones that ecologists would call a refugium, a place of refuge. We see that on a small scale in the aftermath of, for example, like when Mount St. Helens blew up in May of 1980. That area around particularly to the north side of the volcano got completely devastated. It was a barren lunar landscape, yet there was a few little places where you see life was able to, by whatever means, survive. Typically, like if you have a blast, we see this in the aftermath of the Tunguska event of 1908. If there's a hill, the blast wave is coming across, it's flattening everything, it's snapping trees off, but in the lee side of that hill, there might be a zone where you're basically protected from the blast wave, and you'll find a few standing trees there that may have survived. And from these pockets of life surviving, it extends out and reclaims the wasteland. It reclaims the devastated landscapes. And so I think that perhaps we're kind of looking at the same model for civilization. There may be places where pockets survived, but the problem is, Sean, is that in the event, in the aftermath of an event like that, most people who are still survived are going to be entirely preoccupied with surviving from day to day, because basically whatever cultural infrastructure has been in place that allows people to survive as a group, as a community en masse, that's pretty much gone. And so now what happens is societies are thrown back into survival mode.
Right.
And, you know, Plato talks a lot about this in his two dialogues, Timaeus and Critias, where he talks about Atlantis and how the Egyptian priests would tell Solon, you know, you have repeated destructions and then knowledge gets lost.
Right.
Because people become, you know, preoccupied with just the day-to-day necessities of survival. Now, if you have this, if you have any kind of a tradition that's perpetuating knowledge, that's going to be a different situation there, because what it suggests is that there was somebody who anticipated a catastrophe and was able to take steps to preserve as much knowledge as possible in the event of a catastrophe. And when we see the very dawnings of civilization, which are completely incongruous with the conventional models, is that all over the world we see kind of the same pattern happening. We see hunter-gatherers, we see a nomadic society, small groups. We see maybe some subsistence farming, like we had in the Nile Valley for a few millennium.
Sure.
Well, and then all of a sudden, within a generation or two, they're building these incredible monuments that require sophisticated engineering skill, mass organization of labor, knowledge of geometry, knowledge of astronomy. You know, it goes on. So, and we see this phenomenon. It's, you know, it basically just flowers so quickly that you wonder, what was the impetus? How is it that you had millennia of basically subsistence farmers or hunter-gatherers, and then within a couple of generations, they're building these extraordinary monuments? See,
I don't buy it.
No, it doesn't make sense. And
no.
Right. So, but here's the thing. What we're seeing now is just, you mentioned it earlier, in the aftermath of a catastrophe, what it appears is that you know, there was a crash in the human population, certainly in North America. I don't know if we got into that last time or not, but there's some very interesting graphs showing evidence of human occupation of some of the like late Pleistocene Clovis sites, which appear, for the most part, abandoned across the continent. At the same time, the megafauna disappeared, which of course completely contradicts the notion that the megafauna disappeared because they were hunted to extinction by, you know, roving bands of hunters throwing spears.
Right.
So what that means is that, you know, if you're going to start building a large architectural infrastructure, wherever it is, if it's monumental earthworks in say North America, where we see the very first manifestation of these monumental earthworks going back to between 5,000 and 6,000 years ago. Interestingly, when the first occurrences of the Old Kingdom in Egypt, or the Sumerian ziggurats, or some of the architectural activity in the Indus River Valley, we see what's interesting there is the contemporaneous manner, in that over, say, a period of only 2 or 3 centuries, it's like, you know, all these cultures were asleep, and then all of a sudden, you know, the alarm clocks went off. Everybody got up, picked up their trowels or their wicker baskets and their deer antlers, and they all went to work, and they started creating these massive monuments of stone and earth and timber, which of course the timber doesn't really remain to the extent that the stone and the earth does. But when we look at North America, we have Poverty Point, Watkin Break in Louisiana, some of the very first examples of this monumental earthwork architecture, which of course one of the interesting things is in all of these cases, it requires a mass mobilization of society.
Right.
In the old kind of, to me, these obsolete models, you had the egotistical pharaoh or whatever, and he had everybody, it was all slaves doing this. I don't know if that necessarily makes sense. Because for one thing, it seems that the simultaneity of this phenomena occurring all around the planet, say right around the same time, to me, what it looks like is that coming, because I'm a builder and I know this, that I can't build anything if I don't have a labor force, if I don't have a pool of labor to draw from. And you need materials, you need labor, right? You've got to bring those materials from somewhere. In the case of, in Egypt, you had to quarry enormous masses of stone. In North America, you had to excavate enormous masses of soil and earth to begin to create these ringed structures and these truncated pyramids that we find all over. So what it seems to me like is that you have a period of, say, 3,000 to 5,000 years in that immediate post-glacial world where even if somebody had the knowledge to build these structures, had the engineering knowledge, had the astronomical knowledge, had the geometrical knowledge, they didn't have a labor force to do any of this. See, you had to basically repopulate the planet.
Right.
This period, say between 6,000 and 10,000 years ago, actually was a relatively benign period in Earth history. Climatologists used to refer to it as the climatic optimum. That term has been kind of dropped now in favor of the hypsothermal, and the reason is because the climatic optimum was 2 to 3 degrees warmer than the present world, and it's not politically correct to say that a world is 2 degrees warmer might have been the optimum world. See, so they abandoned the term optimum. But during this time, basically what you had in that post-ice age world is you had a lot of habitat destroyed in those transitions. Within a millennia, nature had become pretty much recouped a lot of that. So, I mean, you can devastate a vast area of forest, and within a millennium, you're going to have forests growing back. Another few centuries, the whole devastated landscape around Mount St. Helens that I mentioned earlier is going to be completely forest covered, and it's already reclaiming. I might mention also that we've seen, like in the case of Mount St. Helens, we see a parallel example to what happened almost with the entire planet during the Cretaceous Tertiary mass extinction of dinosaurs, when there's really robust evidence that the Earth got slammed by something really huge, right?
Right.
In the aftermath, when you have these devastated landscapes, the first thing you see, the colonizer species of plants, the pioneers that move in, are ferns. They're the first thing you see. So what we see, this fern layer, this global fern layer at the KT boundary 66 million years ago. And this was like the first restoration of the biosphere in the aftermath of that. We also see, in the case of Mount St. Helens, we see ferns being the first thing that's growing out of that ash layer, that volcanic ash layer. Those successive generations of ferns then generate the organic material that allows the next stage of ecological succession to take place. Well, they're finding the fern layer at the Younger Dryas boundary as well. So this is very interesting. We see these parallels here.
Sure.
I guess what I'm getting at, though, is that it would seem that population crashed in the wake of the Younger Dryas, and it took 3,000 to 5,000 years for enough repopulation to take place that you would have even had a labor force suitable to undertake these massive infrastructure projects. Then what that brings, the mystery that it brings in is, if that's the case, if we're seeing a transmission of knowledge from the end of the Ice Age to, say, the dawning of recorded history, which we'll think of maybe terms of a 4,000-year window there, that means that there was some organized effort to preserve and perpetuate this knowledge until such time as you had the resources and the means to actually make it manifest on the earth. Sure. Then, of course, that raises the question of, when we push it back, what was the source of that knowledge? And of course, here now we begin to get into this idea of what existed back during the Ice Age. And
right.
This is where this is an area where Graham Hancock is really focused on. He's focused on what he refers to as the mother civilization. And of course, Orthodox scholarship has really slammed him for that because he looks and realizes that the dogmas have major holes in them. And he's willing to speculate, and we have to be willing to speculate here because there are bona fide mysteries here. There are bona fide things that are not explained within the Orthodox models of prehistory. And for decades, they've been shoving this kind of anomalous evidence under the rug, but it's to the point now with the rug is just like this mountain with stuff spilling out from every side of it. And there's no more room to push that stuff under the rug anymore.
Right.
So we have got to reevaluate our own history because there's a much deeper, more complex story when we get back. It's not just barbarism when we get back to, it's not just primitive cultures when we get back to the Ice Age. It certainly does seem like there was something else going on. And I think we're only at the very beginning of figuring out what that was. But we kind of see the fingerprints of this in multiple different places. And, this is where Graham Hancock's work is so exciting. And when somebody like any researcher into these kind of anomalous areas is going to go down some dead ends. You're going to go, okay, what's the explanation for this? You're going to try something out. It maybe doesn't fit in the end. And what happens is the critics then will seize upon that as if going down one dead end discredits every single thing you do.
Yeah,
that's kind of the tactic right there. See, this is the tactic they employ. I've seen this deployed against Graham multiple times. It's totally unfair because he's looked at a lot of things, and we need people who are willing to speculate because there are major holes.
Yeah.
And no matter how you how you model it or how you describe it, there are inconsistencies, omissions, contradictions, and it all points to there being something deeper going on with our history.
Yeah, I think it's a good point to make that, first of all, for the folks who are listening who may be critical of speculation is part of the scientific model. That's the first bleeding edge step that you have to make before you try to put together a hypothesis, which you can then put some type of testing around to figure out your hypothesis. And by the way, if your model that exists doesn't explain absolutely everything to the nth degree, it's fucking wrong, and it needs to be improved. And so if you have a status quo model, like the model that exists today to explain how we got to where we are, and if it has any holes in it, it's fucking wrong. It may be partially correct, but it's not completely correct, and thus we need to fill in those holes to answer those questions of how did these Drumlins really get here? Why was half of the planet's megafauna wiped out at the same time that a large number of humans were wiped out? And why was it that we all came from Africa? Well, maybe because the African continent was one of the least affected continents from the impact events that wiped out just about all other life on the planet. And we rebirthed from there, which is why Africa has the world's record for the number of species that exist here on the planet still, right?
Well, Africa does actually. Africa preserved about 80 to 90% of its Pleistocene megafaunal species. So clearly, if you look at loss of species, which would be a barometer, if you will, of loss of habitat, and the loss of habitat is going to be directly related to the severity of the catastrophe. What we see is North and South America had the greatest species loss during the terminal Pleistocene events, which 75 to 80% of megafaunal species in North and South America bit the dust. And that's, Eurasia lost about a third to 35% of the species. Africa lost 10%. So most of the large species you see in Africa today are remnants of the Pleistocene megafauna that did not go extinct in Africa.
Either that, or the Africans are not as big of a group of assholes as the hunter-gatherers that killed off all the rest of the megafauna on North America were, because we obviously were carrying around, and we're much better with the spears than the African folks were, because we were able to kill off all the megafauna with spears versus Africans not being as effective.
Science.
Maybe, Sean, but
is that one of my speculations that might be off the path?
I think there's a high degree of probability there.
Well, I'm sorry. I was just trying to be devil's advocate and taking the approach that we killed off all of the woolly mammoths with sticks.
Makes sense if you don't think about it.
Well, I almost feel like it's the fringe researchers who are being the devil's advocates here. Because there are, like I said, I mean, there's so much about we take the overkill hypothesis as an example. It just doesn't make sense. And the more you think about it, the less sense it makes that you could, wipe out, half the planet's megafauna in a matter of 1,000 years with spears.
Right.
Doesn't make sense.
No. So what evidence do we have in the stuff that you have shown people before, and maybe some of the stuff that you've worked on recently, that shows evidence that a previous human species had some knowledge of the solar system that we, until just recently, lacked? Show us some of that stuff that you wanted to share with us on the sacred geometry path that helps us put together the full story that supports the fact that a catastrophic event could have reset society to a certain extent.
That's all you want me to do?
No.
Well, since you asked,
just
and
that.
If you can, let's go ahead and resolve the quantum physics and the classical physics model while we're at it.
Sure. Well, Sean, I mean, I think it's going to require a couple of episodes really to get into this to the extent that, we could actually make a solid case.
Approved.
Because
all right, this is part one.
Here's the thing. Like I said, I look at, the evidence, if you're like a forensic detective and you're looking at a crime scene, you're looking at different kinds of evidence. Some evidence might be really obvious, like a corpse laying on the floor or a pool of blood or some strange footprints that you can see with the naked eye. Then there's other evidence that's a lot more subtle, where you like fingerprints. You don't really see a fingerprint until you've dusted for it or take some DNA samples from a cigarette butt or whatever, or right. So there's some kinds of evidence which you can see clearly. When we're looking at the evidence for the catastrophe at the end of the last ice age, there's evidence like a coulee, a recessional cataract, a dry fossil waterfall, for example, that's 400 feet high. That's like something you can see with the naked eye.
Sure.
Then you have things like magnetic grains, microspherules, nano diamonds. These are more like the fingerprints. You've got to have, scanning electron microscopes and sophisticated technology to be able to identify these things. So we're kind of in the situation now where when we get back to the Ice Age, when we're starting looking at evidence for ancient cultures, we're dealing more with fingerprint type stuff.
Okay.
We're not really seeing, I'll qualify that in a second. We're not really seeing, okay, well, here's the remnant of a city that's 15,000 years old or 20,000 years old, right? We're not seeing that kind of stuff. However, there are things like, I can cite examples, the Sphinx on the Giza Plateau, which clearly shows extensive water erosion. So what we can argue is that the Sphinx had to already be there when there was enough water to erode to cause this extensive erosion, right?
Right.
When was that? When and most of the evidence to me suggests that the what's called the pluvial period in Egypt, when there was extensive rainfall, occurred around 12 to 13,000 years ago. If that can be correlated, then that obviously implies that the Sphinx was already there when the rains fell. Okay, so that's more like macroscopic evidence, right? Some of the huge stonework in South America, some of the huge stonework, for example, at Baalbek, may go way, way back. I mean, that may be some of the macroscopic evidence, something that we can actually see because we do know that cultures all over the ancient world were able to move and transport enormous loads. When we're looking at stones that are 200 plus tons, that's a big deal for today. I mean, we would have to employ huge cranes to move a 200-ton stone. You don't just move a 200 stone without bringing in a whole lot of industrial infrastructure in place to move that stone. If you're moving that, right? And yet the idea that, ancient peoples who were hunter-gatherers were readily moving stones from a few tons up to 50 or 100-ton stones is one of those things that just doesn't seem to fit. And I find it interesting that a lot of the academics and stuff that are proposing these ideas have never actually been out in the field trying to move a 1-ton beam, for example, and lift a beam up into a building that when you don't have a crane, right? It's not that easy. It's a lot of work. And when you think about that, you go, wait a second, they were doing this, moving millions of tons of stone like this all over the planet. It doesn't make sense. It just doesn't make sense. What's the motive? What is the motive? Please, come on, tell me what the motive is. Well, it was their religious, it was fertility rites, or it was their religious ceremonies, or whatever. That I'm not buying that. I just, that's where my skepticism kicks in.
I did this so I could get laid.
I was trying to impress a girl, so I built this pyramid. Total backfire.
I got to say, when I think about some of the contortions I went through once upon a time in my life to get laid, maybe it's not so far-fetched. But in any case,
well, I like
we won't go there.
Well, here's the thing, though, and I got to tell you, we had the same conversation just a little while ago where I was like, and we're just talking about the science of some of the people who had been on Joe Rogan recently about Bob Lazar and talking about element 115 and about how it, and I was kind of explaining some of the science about how a key creates a keyhole into the quantum mechanics, and the quantum mechanics keyhole, because it's infinite in all directions, the keyhole comes to where your key is when you create that key. But when you have a key that influences one of the non-local fields, such as the electric field or the electromagnetic field, where you can actually throw and focus a field anomaly and a field reaction based on your classical model Newtonian physical manipulation of those things, it wouldn't be very difficult if you have the key that influences gravity to then create a gravity bubble that you can project a short distance away and take a 20,000-ton rock and make it to where you can literally push it with your finger. We do that same type of field manipulation with other fields today. It wouldn't be very tough if you have the command of that gravitational science to focus that bubble on something and be able to move it. Because, the only resistance that you have in being able to create a pyramid isn't going to be your atmospheric resistance of pushing the rock through the air. It's going to be the gravitational friction that is caused by, the mass sucking the rock to the earth and then having you overcome friction and gravity to be able to move that rock. Well, if the point that you have negated that force by creating a bubble that has manipulated the field, you can literally push that rock with your finger into place. And if you have that type of technology, obviously you're going to be cutting with lasers as well. So, you can poo-poo all the ancient alien theories that you want, but we're coming to a point where science is making it frigging possible to do exactly what we're talking about in being able to lift things and move them, because gravitation is no longer a limitation for us. And so on the sliding realm of possibilities, of where you have a grayscale of all the possibilities, which is how the whole universe works, by the way, on the one end of the scale, you have a small possibility that they actually created a workforce that was robust enough to move these huge rocks, and they rolled them on greased logs or whatever it was, and had tons of people with ropes pulling these things along inches at a time to finally get them into place and create something as huge as the Egyptian pyramids. Okay, so that's on the grayscale possibility. You have that here out to the end. On that same grayscale of possibility, you have the ability to manipulate gravity and create the limitation of your biggest foe, to remove that from your ability to create that large pyramid. And you have these structures all over the earth. I mean, we have not just the pyramids, we have Stonehenge and things like how the hell do you get that rock way up there in the air to put on top of the other rocks when it weighs so much in comparison to gravitational pull of the earth, unless you're negating that gravitation?
Well, you can actually do it by mechanical means.
Oh, sure, you can.
I don't, and that I don't rule out that they were utilizing mechanical means. But your explanation, it could be lines of it could be a plausible explanation that they had some means of manipulating gravity. I certainly don't rule that out, because again, the idea is that when you're doing something like that, you employ whatever technologies make the job easier.
Sure.
So, I would see a combination of perhaps mechanical technologies employed along with perhaps some unknown or forgotten technology. Because to me, relying totally on mechanical means or brute force is not adequate to explain the phenomena. I'll also mention the largest rocks typically that seem to be quarried and transported are in the range of 100 to 200 tons. And those are isolated examples. A 20,000 ton rock, there's no examples of that in a temple, but we do find 20,000 ton rocks that have been glacially transported by nature.
Yeah, and that was just my ignorance of forgetting the math that I was on the scale of the math that I was talking about. And I'm by no means saying that there's a guarantee that we were manipulating gravity, but I'm saying that could be on the realm of possibility something that exists in grayscale.
I say let's look into all the possibilities there, and like I said, I mean the evidence of ancient peoples manipulating huge masses like that just doesn't make sense if you're relying strictly on manpower or mechanical technologies. We could get into some of that in a future discussion. I don't have these notes here, but I have done a little bit of research along those lines, and have some interesting suggestive possibilities that we could explore in a future podcast.
Awesome.
Yeah. So I was thinking, since we've got maybe 20 minutes left, that we should look at a few things as far as I try to pull up something here that might relate to some geometry and how that was employed, because geometry is actually a very effective vehicle for preserving information, especially when it's manifested in an architectural form, because architecture tends to endure, especially if it's stone. So I am going to very quickly, we're going to move through some slides. Is that okay?
Sure. Sounds great.
Okay, let's do that. Let me know when you can see this screen.
Okay. Bingo,
it's there. Good deal. Okay, so this is a very typical representation of the idea of God as architect of the universe, who employs the instruments of geometry. Let me see if I've got a better version. We've got here, this is the frontispiece to a medieval Bible, as Jesus in his capacity as geometrician of the universe. Now, this idea was actually quite universal. Here we find from the 12th century, as it says here, a synchronicity from China discovered by Carl Jung. Creative gods with compass and square, their serpentine bodies entwined like the DNA double helix. Now you'll notice this is Fuxi and Nuqua, and they hold compass in, this is Fuxi holding the compass in the right hand, Nuqua holding a square and a plumb bob in the left hand. And it's through the manipulation of these instruments of geometry that the universe is brought into being. And we see the star patterns around here. For example, there would be that would be Pegasus, the square. This would be the Big Dipper here. This is probably Gemini. Some of these are obscured over here, so we can't see what they are. We see the 12-fold division of a circle up here, which suggests the great year model, which and the circle of the year, which has a 12-fold division. It goes way back. Yeah, here's a better version of.
Randall, I got a quick question about the last thing.
Sure.
I think when a lot of people hear compass, they think a little thing that points north and south. But could you elaborate what we're referring to when we speak of compass in this context?
I am going to stop the share for a second. And this is what we're talking about right here.
Okay.
A drawing compass. You see where you have a point which is fixed, and you have a which is called typically an arm or a limb of the compass. And so you have a fixed limb and a moving limb. And it's through this dynamic relationship between the fixed and the moving, just like with the Tao Te Ching or the I Ching, for example. You have the 64 hexagrams, and you have lines that are fixed and lines that are moving. And it's through the interplay of these, the fixed and the moving, that all of manifested creation comes about. And that's the idea here, is that you have in the compass, you begin with simply drawing a circle. That's the fundamental act of geometry right there. So this is the compass we're talking about. We're not talking about a directional compass. We're talking about a drawing compass by means of which we draw circles. Now, on the building site, you would use a pole stuck into the ground, and you would have either a knotted rope or a chain with links that could be counted, and you would draw circles by that means. So let's go back to the share screen. Here we see, and see, there's kind of a Gnostic version of Jesus, which is Jesus as Tecton. He's described as Tecton, which means the builder, right? So the idea here is that, in these Gnostic or esoteric concepts of early Christianity, Jesus was an architect, a builder, right? As was God, Yahweh, in also within the Gnostic concepts. In the Masonic concepts, God is envisioned as an architect who employs the principles of geometry to create the universe. But as I was just showing you here, that idea is also going to be found in other cultures, here, the Chinese culture as well. So this idea of geometry being the basis of creation is actually very universal. So I'm going to keep moving here to show you a few examples. Here's the stretching of the cord. And what I'd like to do maybe is, when we get some better weather, I don't know, maybe we could do this. We could go outside and we could actually do a cord stretching by putting a staff in the ground and actually demonstrate. This is something I've been wanting to do for a long time. I used to do it, but for classes and stuff back in the 80s and the 90s, but I don't know if I've ever actually recorded it. So I'd like to actually record. Here's how you can do it. Here's how you would go out, and here's how you would set up and create an east-west axis and a north-south axis, and here's how you could lay out the geometry on a building site, create a template, and use that template to create a structure and orient that template to the movements of the heavens, which, of course, see, when you build a temple using sacred geometry, the idea you got to keep in mind here is this is a structure you almost have to envision as a frozen cross-section of time. You take the continuum of temporal change. Temporal means time, right? Tempo, time, right? Okay, tempo meaning time, temple, which is the frozen three-dimensional spatial structure. They come from the same root, you see. And the idea is that in the structure, the architectural mass, you actually have the proportions of geometry that are changing through time, but you have this capture, almost like you're freeze framing the film and looking at this one image, but it really has to be understood as one slice of a dynamic continuum of change. And so the temple is like that manifestation of the intersecting planes of all of the energy at that moment, right? And now that moment is recreated or recapitulated, typically say on an annual basis, where now those geometric lines that define the temple can be extended out into the world at large and define the movements of the heavens. So what they were trying to do was to integrate the movements of the heavens with the fixed earth below, you see. And so the temple was conceived as an instrument of time and a monument to the universe. So their understanding of these temporal periodicities and these patterns within the universe had to be reflected into the structure of the temple. The temple itself then served as a mean between the human level and the higher planetary level. That was the idea, that you could kind of create a resonance between these different scales of phenomena by building the temple, see? And so when, in this diagram here, what you're basically seeing is that the chord is being laid out according to some specific auspicious axis that's undoubtedly going to align with and mark an event on the horizon that was considered to be significant. And that event could be, it could be the solstices, the annual solstices, the position of the sun on the horizon at the moment of the solstices. It could be the equinoxes, which would then give you almost a perfect east-west alignment. It could be the rising and setting of the moon, because there's an 18.6 year cycle of the moon. Because it basically, the moon has a minimum motion and then a maximum motion. That full cycle takes 18.6 years. So out, for example, in the deserts of the San Juan Basin in New Mexico, the Chacoan culture built a series of structures out on the desert floor that are set out to the alignments of the rising and setting positions of the moon, the maximum rising and setting positions of the moon on that 18.6 year cycle. Why did they do that? And why was it so important to embody or to capture those celestial alignments into the geometry and the pattern of the temple or the sacred structure, the cathedral, as the case may be, in the monumental earthwork structures? We'll keep moving here because we're going to run out of time, and I would like to show you some of this. Here's just a typical building site of stretching the line, you see, and I can actually use the same principles that might have been used thousands of years ago to get this first initial alignment, because that's what you want to do. You need an axis and you need a circle. Once you've got the axis and once you've got the circle, you can begin to integrate those in an infinite variety of combinations to develop whatever geometry you want to produce the specific template, right? Template, tempo.
Yep.
Temporal, temple. See, all of these words are interrelated. And of course, this implement here, the plumb bob, you know, it's one of the principal implements that you find in Masonic symbolism, that God holds a great plumb line. Now, that plumb line, when you're holding that plumb line, you think of it as an arrow. The plumb line is pointing to the Earth's center of gravity on one end. The other end is pointing to the zenith. So what you're actually trying to do when you're going to build a structure is you're laying out a coordinate system. You've got an X-Y axes that cross, and they're on the laid out on the ground, and then you've got your Z-axis, which is going to be defined by the plumb bob. Of course, this is what we use today. But I don't think necessarily that the pyramid builders had one of these. But you can simulate all of the functions that you can do with a modern builder's level. This is what we use now on our building sites. We use a laser level, and they're fantastic tools. Just amazing what you can do with a laser level. But we're going to get into a few things here. Let's see. Let's get up to. Okay, so Jay Hambidge, early part of the 20th century. There's a small group of researchers that have recovered different facets of what I think of as the ancient knowledge, if you will. Jay Hambidge was one of these. In the early 20th century, he was an art historian and a geometrician, and he discovered this system that he called dynamic symmetry, which actually turns out to be the basis of the system that's at all ancient sacred art and architecture and so on. Through many ages, some artists, as discovered in their paintings, show knowledge of a special, inherently dynamic and alive geometry. The golden proportion and creation of the root rectangles was presented in dynamic symmetry by J. Hambidge in the early 20th century. A larger view is presented in a coherent survey in Sacred Geometry by Robert Lawler. The system of sacred geometry contains self-replicating and growth properties. It also includes proportions and geometry and irrational numbers of measure that can be determined on site for a builder's purposes, knowing the very basics of the system with compass, ruler, and square. And so this is how it starts out, with a simple square. Now, when you are setting out, one of the first things you do, you stretch that line. Now you need to have a right axis to that line, and that's going to be simple geometry. And I'm going to stop the share here for a second, jump over to a different screen, and show you what would be the simple geometry that, let me know when you can see it.
Yeah.
All right, the vesica. So this is two circles. They've got the same exact radius, and all you do is you draw one circle, and then you move your compass, or your center anyway, however, I mean, because you can lay this out larger, and it can be on a building site. You draw a circle, and then you draw a second circle so that the center of the second circle is on the circumference of the first. And what happens is you create this area of overlap between the two, which is called the vesica piscis, or the vessel of the fish. It's also sometimes called the mystic almond. It's also called a mandorla. And the idea here is this is the basis of all geometry. This was considered to be a very feminine symbol because it was considered to be a representation of the womb, if you will. Because, and interestingly, once you've created this vesica, out of that particular shape emerges all of the principles of geometry. And we'll just go through a few things here. Okay, so here's a red line. That red line is connecting the line. This is called the line of centers because it's connecting the two centers here, right? Now, you'll notice that if you connect the two centers, which are defined as soon as you've done the two operations with your compass, you've got a line, right? Now, at the intersection of the two circles, you've got the ability to create an equilateral triangle with 60-degree angles, and you've got the ability to create a right angle that forms 90-degree angles. So as soon as you've drawn these two circles, now you've got 60-degree angles, 90-degree angles right there. So if you lay this out on the ground, you can now get your right angle. And if you've laid it out in such a way, say, for example, that your line of centers is on an east-west axis or a north-south axis, then automatically when you generate a line at right angles to that, it will be, the other quadrant. So if you've laid this out to your east-west axis, the line of centers, then the line of the two intersections here is going to be north-south. So it generates both the right angle and the equilateral triangle. So it's from the intersection or interaction of those two forms you can begin to generate all of the polygonal geometry, which is, a polygon is a square is a polygon with 4 sides. A pentagon is a polygon with 5 sides, and so on. You can create a rectangle. You can create a vesica. You can create a circle within the vesica. You see, once you've got a vesica, you isolate that and you draw a second circle inside there. And now that leads you to the quartering of the circle, which is basically a universal system of time that's found all over the ancient world. And we still incorporate that, for things such as north, south, east, and west, midnight, sunrise, noon, and sunset, winter solstice, spring equinox, summer solstice, autumn equinox. So this could be a model of space because we can lay this circle out on to the ground, line it up with the 4 cardinal directions, right? And then we can begin to measure from that. We can begin to determine the azimuth is a term for rising and settings of celestial objects on the horizon relative to this cross that you lay on the ground. It can also be used, and we do use it to define our temporal frequencies. The course of a year, we naturally divide into 4 seasons, right? And we think of this, the circle divided into 4 as being the model of the year, just also the model of the day. So you've got the 4 points on the clock face that define the 4 quadrants of the day. And then we have multiple examples of structures that are totally symbolical as well as functional. Chartres Cathedral is one of the prime examples in more recent times of this manifestation of the ancient sacred builder's art. As it says here, it was referred to as the Golden Book of the West because it was considered to be a textbook in the Hermetic science or the ancient science, which could get us back to those things you were talking about earlier, Sean, with, which is something we should come back to at some time. But as it says here, repository of Hermetic, astronomic, geomantic, and geometric symbolism. And here is the portal of judgment, the western facade of Chartres Cathedral as you're entering into it. And if you look carefully up in the what's called the tympanum, which is this area over the door, you'll see the figure of Jesus. And what he's doing, he's sitting within the vesica. And he's holding a book, the remnant of, you can see the book there, it's closed and it has a lock on it. This book represents the esoteric doctrine, the doctrine that was not yet ready to be revealed to the world at large. Now, the vesica gives us very specific proportions. Also, you see here surrounding here, we see the images of in these bas reliefs, we see a lion here on the lower left, we see a bull on the lower right, we see an angel on the upper left and an eagle on the upper right. These represent the 4 fixed signs of the zodiac, which if you go out and you connect these 4 fixed signs across space, it'll form a cosmic cross. And if you imagine that you're looking at the 4 signs of the zodiac and you project those lines and then you connect those lines and you project them onto the earth, now you've got that circle with the divided into 4, except the lines extend out into space and link the 4 fixed signs of the zodiac. Now, what that gets us back to in our discussions, like in our last episode and further, is that there seems to be a frequency to the cycles of global change that has a high degree of correlation with this particular periodicity as defined by these 4 ages of the world. For example, if we go as our vernal equinox is now transiting out of Pisces towards the star pattern of Aquarius, we can look across the axis to the other side, and we're seeing that the corresponding other end of that line, like a hand of a giant cosmic clock, is moving out of the constellation of Virgo and into the constellation of Leo. This is dated around 12,960 years ago if you use the sacred numbers that have come down to us through various venues, right? Well, now look at the dating of the Younger Dryas boundary, 12,900 years ago. So like there's this perfect correlation almost between the traditional concept that we've inherited from some unknown source and modern scientific confirmation that there is a temporal frequency that seems to be very consistent with the models of temporal change that have come down to us through various mythologies and through symbolic venues and so on. So that's what these four beasts here represent, is those 4 fixed signs. The eagle is usually is always taken as a substitute for Scorpio because Aquila, the eagle, rises at the same time as the constellation of Scorpio. And so when you're looking at these images here and you're using them sort of as a cosmic clock, what you're doing is you're looking for the times of year when each of these constellations begins to rise again and become visible from the northern hemisphere. Now, if I back up to this and I show you this, right? So I've got this cross formed within the vesica, and then I've got a rectangle superimposed on the vesica. Can you see that?
Yes.
Okay, so the rectangle has the same length to width proportions as the vesica. And we can use a little simple Pythagorean mathematics to find out that that relationship is the square root of 3 to 1. right? If we set out our line of centers, our initial starting radius as one unit, whatever unit, a
Right.
foot, a yard, a meter, a mile, it doesn't matter. The square root of 3, which is roughly 1.732,
Right.
times that will give you the height of that rectangle. Okay, so now that, when we come back to this image of the portal of judgment, what we see here is that as you enter the cathedral, the vesica up there in the tympanum is basically giving you the proportional template for the whole cathedral. And then it's recapitulated, because if you look at the door underneath, the proportions of the very front, the door you open and enter into, is a root 3 rectangle with the proportions of the vesica.
Wow.
You see? So right there, they're giving you this geometric symbol that really only the initiates would have really been aware of, because they've been taught these principles of geometry. So when they're trained, when they look and see something like this, they're immediately going to see that this is like the signature figure, that vesica up there, defining the pattern of this 3-dimensional manifestation of geometry that you're about to enter. The door itself that you open to enter the cathedral, the sacred space, is this root 3 geometry in that particular rectangle, which has extremely interesting properties, which make it very useful for builders. In this particular image, you see that the whole ground plan of the cathedral is based upon that length to width ratio of the vesica. And when you superimpose the root 3 rectangle on this and begin, there's a process of subdividing that rectangle, which we won't have time to get into today, but we could do it in another podcast. It gives us the proportions and the layout of all the internal structural elements, walls, and so on. So it's all an act of geometry. Here is the root 3 rectangle superimposed upon the cathedral. We can find many examples of this vesica showing up in cathedrals of old. Angers Cathedral, sometimes this is referred to as Christ in Majesty. And there's, like I said, many examples of it. Well, we could get into discussing some of this symbolism here. It's really profound stuff. The falling angels above, and all of this has deep symbolic significance. I mean, pretty much everything you see here, all the array of circles at the bottom, the royal arch, as Masons would call it, which actually is a symbol for the vault of the heavens and the zodiacal band that's stretching through the sky. Here's St. Mary's Chapel, Glastonbury, which is, of course, associated with the Holy Grail. It was considered to be mythologically, or according to legend, one of the places where the Holy Grail was kept. And here's the floor plan of St. Mary's Chapel, which was, see, when, I'll go through the story really quick. In the post-crucifixion, Joseph of Arimathea, through a miraculous succession of events, was able to procure the Grail. Joseph of Arimathea was the one who took the Grail, and this is actually referenced in the New Testament, took the Grail, and when Christ is hanging on the cross, captures some of, when the wound in Christ's side opens up, blood and water flows out. Joseph of Arimathea collects this sacred substance into the Grail, seals it, and sails for Great Britain. When he gets to Great Britain, he presents himself to the pagan chieftain Arviragus, or Arviragus. Arviragus gives him a tract of land, and Joseph of Arimathea, with his 12 disciples, builds a circular chapel. And this circular chapel was actually small, and reconstructions of it have suggested it had a diameter of 39.6 feet. So that chapel was eventually encased in lead. It existed. Once it was encased in lead, it was preserved for centuries. Then in around 1000 AD, a cathedral was built there, but the cathedral was built in such a way that it preserved the dimensions of the original chapel that had been laid out on the ground by Joseph of Arimathea. That cathedral burned down. Another cathedral was built, and on the eastern end, western end of the cathedral, there was an abbey, a chapel built, and the original dimensions of the circular chapel were preserved in this particular structure, and it's 39.6 feet wide, and it's laid out on a perfect Route 3 rectangle and has the proportions of the vesica, and it's of course dedicated to Saint Mary. So again, it's an image of the goddess, if you will. And there is the Route 3 rectangle superimposed upon it, to show you that particular proportion was at the basis of this chapel. Here's Buddha seated within the vesica, so it's not strictly a Christian concept. In fact, it's anywhere where you find people's using geometry, this principle of the vesica was understood, and it was considered to be a sacred image. So, as we say there,
that's
and
pretty.
here, yeah, the Bishop's Eye on the south side of Lincoln Cathedral in England. Notice two vesicas side by side within the greater circle of the stained glass window there. Like it says, the rose window is a splendid example of curvilinear tracery where all lines of the pattern are continuous curves. So yeah, the artistry here is phenomenal. And when you get into this, the cathedral building enterprise was truly amazing. But underlying all the complexity and intricacy of the cathedrals, we find the same geometry that we find at work, say, in building the monumental earthwork structures of North America, 5,000 years ago.
Sure.
So it's almost as if there was this geometric knowledge that was passed down some kind of way and disseminated. And
all right, so why don't we do this? Since I know you've got to run, you've got a hard stop that you've got to hit.
Yeah.
So what we'll do is in the next episode, and we'll get together in the next couple of weeks. How about that? Like right after the first of the year, what do you think? You look at your schedule, we'll look at our schedule, and then we'll pick up at Lincoln Cathedral right there and just continue the story, because this is getting really good.
Yeah, I'm sucked in.
Oh, yeah. Part one.
I got you guys sucked in now.
So
there's no turning back, guys. It's too late.
We could turn back?
No.
This bus had brakes the whole time?
That was ever an option?
We're in 100%. We'll do this as many times as you want to, because we love sitting here and talking with you. But we love getting this stuff out into the world, because the interesting part of this is that it's really neat to talk about the geometry. It's really neat to talk about how everything connects together, but there's a bigger message coming. There's a bigger understanding of our origin story, and so that's kind of where we're on our way to. And we love that we're on this trek with you.
Yeah, I'm having fun, man. I was just starting to get excited, and then I realized I got to go pick up my new vehicle.
Yeah, I didn't want you to miss that, so that you didn't have to be walking tomorrow.
I know, right? I've been borrowing vehicles for the last month. I didn't want to rush out, but yeah, let's continue this. And listen, this restaurant I'm building is coming right along. It should be about ready for the grand opening come about early February. So I want you guys to all show up.
Okay, we're coming.
Definitely you, Ben. You got no excuse. You got no excuse, man. And I'll show you some of the hidden geometry that I kind of was able to sneak in on.
All right, so what is the name of the restaurant that you're opening, by the way?
Wheelhouse Craft Kitchen and Pub.
Okay.
Yeah.
Wheelhouse Craft Kitchen and Pub, and it's going up in East Atlanta, somewhere near Decatur. Is that right?
In Decatur, yes.
Okay, so in Decatur. And so obviously Randall's going to be hanging around there from time to time. So if you want to pop in and say hello to him, you got to put that on your radar screen. But they're going to be doing a soft opening. Is that right? Sometime soon, that they need some test folks to test.
Yeah, exactly. Yes. We're going to be doing that. Yeah, there's going to be a soft opening, and it's just going to be pretty much for friends and family, so that the chefs and the staff can get their feet wet and figure out, streamline their operation. And then after, I guess a couple of weeks or whatever, then there will be the grand opening, which will be the public at large. But in the meantime, this is going to be like an invite only kind of thing. You guys come in, and that way, if the cooks screw it up or whatever, the wait staff screws it up, then it's not that big of a deal. We
Right.
supposedly will cut them some slack while they're figuring it all out.
Sure. Yeah. Mess up the meal of a United States Navy SEAL sniper. That's a good idea.
We're great guinea pigs.
I'm a Guinea-saurus Rex.
Yeah, you guys like barbecue? Or
No, hate it.
Oh, okay. I don't know. Do Navy SEALs eat barbecue? I don't know. Do they
We eat anything.
Yeah.
eat anything? Yeah.
They eat anything that doesn't move and everything that does.
Okay, I'm going to have to think about that for a minute.
All right. Well, Randall Carlson, thank you very much for spending time with us today. Again, we'll pick up right where we left off in the next episode. And go ahead.
We can do this again in a couple of weeks, I guess. I mean, I'm hanging around. I'm not doing anything special over the holidays, so
Sweet.
probably even between Christmas and New Year's, I'm going to be hanging around a bit. And I don't know. So I'm open to whatever, getting back together. We don't have to wait months. We can.
Okay, great.
Do it again soon.
Great.
Yeah.
Okay, so for those of you watching, if you want more of this awesome content, hit that subscribe button. Don't forget to click that bell icon so that you can be apprised of when the new episodes release. We're trying to bring you amazing content. Please share this and subscribe and tell your friends about us, because we're not getting a ton of algorithm love from YouTube, but any little help that you can give us will be certainly appreciated. Talk to you soon. Peace.
¿Dónde está mi teléfono?